we're almost finished 2.7. In fact, once we finish 2.7, we'll actually start doing differentiation. So everything we've been doing for the last 2 weeks has basically been building on trying to find a way to find the slope of the tangent line. So we've came full circle now, and we're returning to that problem. And there's going to be 2 solutions to that problem, both involving limits. So here's my first story. Imagine this is the curve y equals f of x, and I am interested in the slope of the tangent line at P. So, you know, we're talking about roughly, there we go, the slope of that pen, right? That would be its tangent line. And down here, it's a little bit steeper, tangent line is probably like that. So we're trying to find the slope of the tangent line at a given point P. And we want to know the exact value, which is the hardest part, right? We don't want to know a nice numerical estimate, you know, which we've done before, but something that's in all respects is the slope of the tangent line. So this is, I'm going to call it method 1. So you have your curve, you have your point P, and what you do is you choose another point called Q, which has an X coordinate really close to this point A. And we call the X coordinate of Q, we're going to call it X. Now, since the function is called y equals f of x, the coordinates of P are going to be A comma f of A, and the coordinates of Q are going to be called x comma f of x. So you couldn't get any more general than that, right? We're going to find the slope of the tangent line at the point P, and P is described as having an x coordinate of A, that's this guy. And what we're going to do to try and find a solution to that problem is you choose another point Q with these coordinates. And we'll assume that P and Q are really close to each other, right? Let's try it the way. Now I can find the slope of the line joining P to Q. The slope of the line joining P to Q is essentially the rise divided by the run, which is the difference in the y coordinates divided by the difference in the x coordinates. And in this case, the difference in the y coordinates is that guy take away that guy. And the difference in the x coordinates is that guy take away that guy. And so the slope of the line joining P to Q, this would be its formula. F of x take away f of A over x minus A. And then you say that you can now find the slope of the tangent line. And the logic goes something like this. If Q is really close to P, then PQ will become really close to the slope of the tangent line. Does that make sense? If you make P and Q get really close together, you've almost got a perfect tangent line. So we will say that the slope of the tangent line is going to be the limit as x tends to A of this guy. Okay, so we now have a way of finding the slope of the tangent line, which I'm calling M tan. I believe they just call it M in WebAssembly. Well, let's see how that works in practice. Suppose I have a function square root of x. And I would like to know the slope of the tangent line when a is 4. In other words, when the x coordinate is 4. Well, the slope of the tangent line M is going to be the limit as x tends to 4 of f of x take away f of 4 over x minus 4. And if I can find the limit as x tends to a, 4, of this fraction, this limit, whatever it equals to, and it'll be a number, will be the slope, the exact value for the slope of the tangent line. Okay. So it's going to be the limit as x tends to 4. F of x is the square root of x. F of 4 is the square root of 4, all over x minus 4. So we need to find the limit as x tends to 4 of this fraction, right? That's basically the rise. This is the run. Now, we've seen questions where you were trying to find the limit of fractions that look like this. Can you remember the name that we gave to the method I'm about to use?
Conjugate?
Correct. And the top is the square root of x add 2, and the bottom is the square root of x add 2. So we're going to use the conjugate method. So the limit as x tends to 4, well, if you multiply this guy and this guy by FOIL, you will get x minus 4. But you can trust me, FOIL it out yourself. And on the bottom, you get these two guys. And what should happen is that you get some cancelling, which we do. In this case, it was x minus 4. And we now have this fella. Don't know why that's so big. And we can put in x is 4 now. So square root of 4 add 2. 1 over 2 add 2. There you go. We have just found the slope of the tangent line to this curve when the x coordinate is 4. And the answer happens to be exactly 1/4. Now, that's not an estimate. That isn't the best guesstimate that we can come up with is a 1/4. That is the exact value. And what we've done is we've avoided the problem of making P equal to Q, right? If you make P and Q the same coordinates, you end up with 0 for the rise divided by 0 for the run, and you can't do it. Do you see how the concept of limits has avoided that issue, right? And that's essentially the trick, how to find the exact value of the slope of a tangent line at any given point. And that's this method up here.
What does it say after when a equals 4?
Down here, when the x coordinate is 4. I'm just paraphrasing what a equals 4 means. It just means the x coordinate is 4. But we have to call it a because the way the formula works, there's already an x, and you don't want to have x and then another x because you get 0 over 0. So one of the x coordinates is called x, and the other x coordinate is called a. So you've got two distinctly different things in your formula. So far, so good. We now have a way of finding the slope of a tangent line by using this formula. Well, there are two different formulas. Here's the second one. Imagine we had this function, and I wanted to know the slope of the tangent line at the point x equals a, right, at P. So we tackle it in a very similar kind of way. We choose another guy over here, but we won't call this guy x. we'll call this guy x equals a plus h. And that gets to here. In slow, we have the slope joining p and q together is the difference in the y's, the difference in the x's. In this case, p will be a f of a, and q will have the coordinates a plus h, f of a plus h. So the difference in the y's is this, take away that. So f of a plus h, take away f of a. And then the difference in these x coordinates is a plus h, take away a. So we get essentially f of a plus h, take away f of a, all over just h. So the slope of the line joining P to Q in terms of A and H's is this formula. So if you want to find the slope of the tangent line, you make P and Q get closer and closer. And the way this has been written, the way that you get Q to become closer to P is that you basically make H get closer and closer to 0. Would you agree A and A plus H are going to be really close when H is almost 0, right? So by making that, so this time the limit is that of this expression.
Is it supposed to be the difference of y over the difference of y?
No, it's meant to be the difference of y over the difference of x. Well, got formulas, right? I just wrote down this little piece from that, and that's the same thing. Right, so we now have a second formula, a second limit formula that's going to allow us to find the exact value for the slope of a tangent line or curve at any given point. I'll show you that happening then. Suppose I want to find the exact value of the slope of a tangent line to the curve y equals x squared plus 3x at x equals 4, which is another way of saying a is 4. Then according to my formula here, the slope of the tangent line is going to be the limit as h tends to 0 of f of a plus h, take away f of a all over h. But since I know a is 4, I now need to find this limit. And somewhere in 141, you were asked to find a guy that looks just like that. And if you got me in 141, I told you that you are going to use this expression in Calculus 1. So if you were wondering why you were learning how to do it in 141, it was to make this step a little bit easier, a little bit more familiar. But I guess 141 is quite a long time away, and you may have forgotten how to find the value of f of 4 plus h. So this is how it works. F of 4 plus h, basically this is f of x, right? Instead of you having x squared plus 3x, you now have this guy squared plus 3 times this guy. It's essentially a substitution or replacement process. So every x gets replaced by this. So you're going to have 4 plus h squared plus 3 lots of 4 plus h. So that's that guy there is him. Does that ring some bells? Is it familiar? Yeah, okay. Then you're going to take away the value of the function at 4. Well, I'm just going to do that in my head. 4 squared is 16, plus 3 lots of 4, which is 12, and 16 odd 12 gets me 28. So if we can find the limit as h tends to 0 of this, right, we're going to get a number. That number is the exact value for the slope of the tangent line to this curve at 4. A little bit different from most of the limits you've seen, but not that far away that we shouldn't be able to figure out what to do. This, the form this is written in right now is not going to be really much use. Agreed? I can't do any kind of factoring and cancelling, for instance. So what do you think I might do first before we start worrying about, the final solution?
Expand it.
That's what I would do. If you FOIL this guy, you get that. 3 lots of 4 get you 12, and 3 lots of h get you 3h, take away 28. Now, after you expand it, what you would do next is collect like terms. So what have I got? I've got an h squared, that's all, so put that there. I've got an 8 and a 3, so that adds up to 11h. And I have got this guy here, 16, plus this guy here, 12, take away this guy here. Do you notice something really nice? 16 add 12, take away 28. You notice anything really nice?
It's 0.
It's 0, they cancel out. So my will shift it up a little bit. You don't need this line, I'm just doing it because it distracts me. There. There, that's a nicer version of that. Okay. Good start, right? Would you agree that's a much nicer looking thing than it was a few moments ago? Where do we go next? What do I do with this expression so that I can find its limit as h tends to 0? Say again?
Cancel the h's.
Right, you got to be careful with that. There is going to be a cancelling of h's, and it kind of depends on what you mean by that. Unfortunately, some people think that h can cancel this h, and you're left with h squared plus 11. That's not allowed.
You'd be left with h plus 11.
Yeah, so basically you factor out an h, which then allows you to do what you said. You cancel an h. And if you make h go to 0, 0 plus 11 is 11. So the exact value for the slope of this quadratic when x is 4, the exact value of its slope is 11. And that is the solution to the tangent line problem. We now have a method to find the exact value for the slope of any function at any given point. And we will do it by either this one or, good, we've got them 2 places. This one, this formula, or this one. Now you may ask, I wonder why we have 2 different formulas. Why can't we just do one, right? To me, that would be sensible. If both, if they work, why do I need a second one? Can't I just use the first one, right, all the time? Or can I use the second one all the time? Theoretically, you could. The main reason why there are 2 different formulas is that For some functions, this formula is less work. And for other functions, this formula is less work. So it's really just a matter of, to make the job of finding, whatever limit formula you use, you want to pick one that's a little bit easier to deal with. So here are the rules. If the function that you're going to deal with is a polynomial, right? It's x squared and x cubes and things like that. Using this second formula here tends to be easier, right? The math is simple, right? So if you're using quadratics, cubics, things that look like that, use this formula. If, however, you are going to be doing square root functions, right? The square root of x, 4 square root of x plus 2, square root of 9x plus 1, that kind of thing. This formula here tends to be easier to deal with, right? And it's not that you couldn't swap places, because you could, but you'll probably find the math uglier if you use the wrong method. So if you're doing a question and it gets into a scary place where it just looks so ugly, you're not even sure what to do next, you might want to stop and pick the other method, because it sounds to me like it's an example of that situation. So square roots, use the top guy. Polynomials, right, powers of x, use the bottom guy. And the third situation that we need to deal with is going to be fractions, rational functions. And when you do rational functions, it depends on who you ask which is the simpler, but I tend to do this one. I think this one tends to be less work when it's fractions. So if you see a square root, go for this guy. If you don't see a square root, use that guy. And they're the only ones that you're actually going to deal with using this method. You're either going to get square roots or cube roots, or polynomials or rational functions. In a lot of the questions, they tell you which of the two formulas, that's this one, I should put those red things around them. This one here, or they tell you to use this one here. So whichever one they tell you to use, that's the one you should use. So jump right in. This is a homework question, number 1. The function that we're going to find the slope of the tangent line is this guy. The point that we're going to find the slope of the tangent line is that guy. And we're going to use it using both methods. So in question 1, we're being asked to find m, the slope of the tangent line, using the limit as x tends to a guy. And in the second question, we're going to find the limit as h tends to 0 method. So let's do it both ways. To do method 1, what do I need to know? Well, I need to know who A is. Now, in this coordinate, it's -3, 12, so the x coordinate is -3. That means A is -3. So, slope of the tangent line is going to be the limit, the overall limit, as x tends to -3, of f of x, take away f of -3, all over x take away -3. So here's that guy. Right, f of x is basically x squared plus 7x, take away f of -3 is that number. So it's basically take away the y coordinate, just this one. And on the bottom, you get x plus 3. Okay, we need to find the limit of this fraction as x tends to -3. Do you recognize a question where factor and cancel method would be the most obvious direction to go? So factor and cancel. So I'm looking for two numbers that multiply together that give me plus 12. But when I add those two numbers, I get plus 7. And what are those two numbers?
X plus 4 and x plus 3.
Can't argue with that. From the few times that we have done them, have you noticed that whatever the bottom is, one of the two terms in the top will be the same guy? Have you noticed that? Right. So this quadratic has to factor as x plus 3 times something. 12's not that hard to do in your head, but can you imagine it might be 120? In which case, isn't it very helpful to know that one of them is called x plus 3, because then you only need to find the second one. And according to the method factor and cancel, they cancel. And so we now have the limit as x tends to -3 of x plus 4, that's it, which is -3 plus 4, which is 1. So this function, the slope of the tangent line at that given point is going to be 1. And if I do the second method, this one here, the slope of the tangent line is going to be the limit as h tends to 0 of a, which is -3 plus h, take away f of -3 all over h. So x squared becomes this guy. Take away f of -3, so you take away that, over h. Now, I know that this is a bit messier and you have to FOIL this out, and that might seem, which it is, a lot more work. But can you trust me that once it's x cubed or x to the 4, this extra work is going to be really helpful? Because if I try to do this method with an x cubed, or God forbid, an x to the 4, wouldn't you have to factor a cubic or a 4th power polynomial? And I don't think any of us know how to do that, right? It's just not practical. So back to this one here. This guy will get you 9 minus 6h plus h squared. This guy will get you -21 minus 7h. And this guy gets me 12. If you take this number and this number and this number, they always cancel. So if you're using this method, the one I'm doing right now, the numbers on the top will always cancel out. They will always become 0. If by any chance you get a +3 left over, you have done it wrong, and go and figure out where it went wrong, because it won't happen the numbers always cancel. Now, if you look at what's left, we have an h squared minus a 13h over h. Now, that's much easier to deal with because the next few lines are pretty much the same every time. You pull out an h as a common factor. You can then cancel. You're now left that is interesting. That is very interesting. Well, let's take it to the end and show you that something's gone wrong. Either I screwed up here and the answer is not negative 13, or I screwed up here and the answer is essentially not 1. So let's see if I did this. That guy's good, that guy's good, that guy's good, that guy's good. There we go. That should have been 7h, which makes that plus h, which makes that plus 1, which makes that plus 1, which makes that plus 1, makes that plus 1. So now it works. 7 times h is 7h. Don't know where my negative came from. So we have two distinctly different methods for finding slopes of tangent lines. So far so good. Now, let's return to one of the questions I just did and add an extra type of question. So we had this guy, we had the point -3, -12. We already know the slope of the tangent line, it's 1. The third question would be, find the equation of the tangent line. In this situation, right? So essentially it's going to be at the point -3, 12. Right, so we're going to find the equation of the tangent line, right? Y equals 2x plus 5, right? That kind of guy. And right now, I know the slope and I know the point. So I should be able to get the equation of the tangent line. And there's part of it written down. Can anybody remember the formula for finding the equation of any line? This just happens to be a tangent line at a given point with a given slope m. Okay. If I call this guy x1 and I call this guy y1, does that help? Equation of a line passing through a point with a given slope. It's called the point slope equation.
Should it be that y not -12 plus 12?
Oh, as a number, you're right. You're correct. There's your general formula. So it's going to be y take away -12, like you said, plus 12. The slope is 1, and it's going to be x take away -3. So y take away the y coordinate equals m times x take away the x coordinate of the point that you know. M will be the slope. So in this case, you get that plus 12, and you get x plus 3, because 1 times that don't make any difference. If you then subtract 12 from both sides, this guy represents the equation of the tangent line. And very often they do one more thing. They get you to use, I would use Desmos, so I'm typing in right now, to figure out which one, what it looks like if you graphed it. Hang in there for just a few seconds. Here we go. Let's put that together. So here is Desmos. I'm going to put in the original curve, which in this case was the quadratic, x squared plus 7x. And there it is. Looks a bit like that. I'll probably adjust the windows in a few moments. The equation of the tangent line is y equals x plus 3. No, it wasn't. It was x minus 9. There we go. And if I zoom right in here, there. Would you agree that the blue line is a tangent line to the curve at that point there? And click. Do you see the point had coordinates -3, -12, which it was in the question? Isn't that where P is? And can you see the slope, the tangent line slope? Everything matches. So if I zoom out a little bit, see the bigger picture, one of your 4 pictures in your homework will look like that guy, and you will pick that as your answer. Okay. Any questions? So we're going to spend what's left of today and definitely tomorrow looking at finding slopes of tangent lines using one or other, typically you only use one, of the type we've done today. Okay. There we go. Right, so the next one that I want to show you is how to deal with fraction functions. So the one I'm choosing is question 4. So I've already done what quadratics today, right? We've seen what they look like. We did a square root, right? That was one of the very early ones we've done. So the only third type that you're going to deal with are fractions. And of course, you always keep the best till last. So the rational function, the fraction function that we are going to deal with is this guy, take away that guy, and the point that we're trying to find the slope of the tangent line is this guy. So basically A is 3. I kind of have to know what A is to put the formula into gear. We are going to find the slope of the tangent line at 3. And once we find the exact value for it, we're then going to find the equation of the tangent line as well. I'm not so sure how much of that will get done, but we'll try our best. So we have a decision to make. I can use this method, or I can use that method. Both will work. And for rational functions, it depends who you ask. Do you think this one's going to be less work? Or do you think that one's going to be less work? You know, it is what it is. So what do you want me to use? Top one or bottom one?
Top.
Okay, so we are going to find the slope of the tangent line by finding the limit as x tends to a becomes x tends to 3 of the value of the function at x, take away the value of the function at 3, all over x minus 3. So it's going to be x plus 3 over x minus 4. Take away f of 3. Now I could plug in 3 here and do a calculation, but isn't the y coordinate what you'd end up getting? So it's negative f of 3 all over x minus 3. Now, when you're doing rational functions, you are going to get a guy that looks pretty much like that every time. There's going to be a fraction plus or minus a number over something like x minus 2, x plus 3, in this case, x minus 3. So at least there's a similarity in what you get. And there is a process for solving this question. Okay, there is a process for solving this question. And it's going to involve us not using a conjugate because there is no square roots here, but we are going to use a method, kind of like the conjugate method. I'm going to multiply by a special version of 1, you know, like x plus 7 over x plus 7. And that special version of 1 has one job to do. Make that x minus 4 go away. Because that's the guy I want to go away. That's the special version of 1 I'm going to do. So we now have the limit as x tends to 3. Those two get written down, and never do anything to these. Leave them alone. Don't foil it out. Don't play about with them. Just leave it alone. Now, on the top, it's a bit messier. I am going to take this fraction and I'm going to multiply it by x minus 4. Now, if you take x plus 3 over x minus 4 and you multiply it by x minus 4, the x minus 4s essentially cancel out and you get x plus 3. Are you happy about the math there? That this fraction times x minus 4, the x minus 4s cancel out and you get x plus 3. Now, if you take this number 6 and multiply by that, you're going to get 6 lots of x minus 4. Do you notice that we've now made the fraction go away, which is the whole purpose of doing that? Okay, what should I do to the top row?
You can cancel the x minus 4s.
No, unfortunately, I know that. It looks at, doesn't it?
Because you, never mind, it's addition. Never mind.
So, but I'm glad you brought that up because it's a very common error that people make, is that they see this and they say, oh, cancel, cancel. You are not allowed to cancel something unless it's a true factor, which means x minus 4 brackets a whole load of stuff, close the brackets. So we will be doing cancelling, but not yet. What will we do instead? Especially to this term. What do you think you should be doing to this term?
Multiply it out.
Okay, if we distribute it out, we get that. I'm wondering when you signed up for Calc 1 that you thought you were going to do as much algebra as we end up doing. So that's what you get when you collect like terms. And it might look like we're in trouble, but we're not. 7x minus 21, the way it's written, isn't much help to me. What could we do to 7x minus 21 that might make it play better with the guys on the bottom?
Factor out the 7. We make it 7 times x minus 3.
Essential isn't that cancel, factor and cancel, right? So now you can cancel, right? Because 7 times something is a factor. X minus 3 times something, it's a factor. They're both factors, so you're allowed to cancel them. And now you get the limit as x tends to 3 of 7 over x minus 4. And at this point, you can then replace the x with 3, and you get the answer -7. So the slope, the slope of this function at that given point, right, the slope of its tangent line is -7. Degree fractions are the ugliest of the 3 that you've seen. Polynomials, square roots, and now fractions. Well, we do have enough time, so I'm going to finish it. I know the slope of the tangent line. I just found it. I know the coordinate of the point that we're going to be using. I can now get the equation of the tangent line. So y take away y1 equals m brackets x take away x1. Y take away -6 gets you add 6. Slope in -7, x take away 3. Distribute the -7. And then take 6 away from both sides. And there you go. You have got the equation of the tangent line. Now, the bit I don't have is draw a graph of what's going on. But essentially, wouldn't you do a function that looks like that? And then a tangent line, which looks like that. And I have no idea what the thing really looks like. But can you imagine that's 3 -6 down here? And you have a tangent line that's going like this. And so the guy you're dealing with might look something like this. You imagine at that point it's a perfect fit. You good? Right, and put your name down now.